features of AWS Bedrock. It's a fully managed service, and I think this now I've mentioned about the service. And this is the diagram which I'm just showcasing around like AI agent, just to understand AI agent. So AI agent is a wrapper around LLM, as we speak before, and it also has a planning component to it, which is powered by the large language model. They are good with planning, so there are different patterns around this. I don't want to go too deep into AI agents. I have previously done a lot of sessions on it. You can, go ahead and look for those sessions on YouTube. I'll share the channel pretty soon. Or there are a lot of resources outside that will be explaining you about it. But I just want to give you this idea, of at least a diagram on this to illustrate some important components of AI agent, that because we'll be building one on AWS Bedrock pretty soon. So there is a planning component which is powered by LLM. They had a bunch of tools which are, it could be calendar, calculator. It could also be a compute, or maybe a code interpreter. So these are all different tools for an AI agent to perform a specific action. And it also has memory component in it, where it stores short-term and long-term memory, because AI agents should be able to remember previous actions. And there could be some attributes that it has to remember long-term as well. Maybe a personal AI agent should remember about your friends, maybe about your preferences and all. So let's get started with what is a vector database. So if you're not familiar with a vector database, it's basically a different from your regular database, in the sense that it stores the data as embeddings and in a multidimensional embedding space, where there are different words which are categorically similar, are geometrically arranged closely in that space. So if you see wolf, dog, cat, these are different animals which are together in this space, and and here there's banana and apple. So the similar words, they happen to be arranged nearby in this in the vector databases. So they're not strictly search. You can do similarity search. There are a lot of algorithms like Euclidean space, cosine similarities that you can probably perform on these databases. That's actually is making all of this possible now. Any of the query that you ask, those are converted into embeddings, and all of the numbers, basically LLM only understand numbers. It doesn't understand your actual literal word. So it's basically a high dimensional vector that a LLM would understand. So any token that you, or any sentence that you ask, a question or an email that you ask for LLM to improve or write, it's all under the hood. Those are all converted to numbers called embeddings, and those are stored. If they have to be persisted, those are stored in a vector DB like this. We'll go through that vector DB. We'll be using a service on AWS called OpenSearch. And retrieval augmented generation is also a session that we have done last week. So in this, retrieval augmented generation is a pattern. The reason why I'm showing this is because we'll be going through some, while implementing the AI agent, we're going through a single pattern called RAG. So in which we have the documents which are chunked, because maybe you have your internal documents that you want to ask questions to. So how could you have any LLM? How could you ask questions to an LLM or chat with those documents? So this is the process that actually helps an LLM to understand your own personal documents. So the data pre-processing step include documents being chunked, which is just splitting them into different chunks, making them go through an embedding model, which actually converts these sentences into higher dimensional these numbers, these vectors, and embedding model actually does that, which converts the sentences of the words into numbers and store them into a vector DB, as we speak before, as we mentioned. And here it's called MyScaleDB. It's a diagram which I got from them, but it's you could actually use any vector DB. And you have this, and basically what happens is whenever you have a question, which is the user query itself is also converted into an embedding model. And then your retriever retrieves similar chunks that could answer your question. Your user query could be any question that you want to ask from your documents. It could be related to your questions around the personal documents, and then the retriever would retrieve the chunk, and then it will add more context to your LLM along with those retrieved documents, and you get the response. So that is what RAG is. I don't want to go too deep into it. We already did a session on this. And it's a very important pattern. This makes custom GPTs possible. I don't know if any of you are aware of custom GPTs. That is how they work, where you upload your documents and you chat with LLMs to answer questions on those custom GPTs. And let's go ahead with, I'm just muting some of the participants who joined just so that we don't get any dissonance. Yeah. Okay, let's go ahead and build a restaurant assistant agent. So that is what we're going to build today with AWS Bedrock agents. So what it does, so this is the overall diagram that we're going to build today. This is a diagram of the overall architecture. So I just want to showcase some of the things that that if you're new to AWS, I would probably give you a very brief introduction to these services. I just want to explain what these are. So this is an AI agent. As of now, this is hosted on AWS Bedrock. We'll be using Bedrock to build this agent. And there are something called action groups. So this is the action group. Action group is nothing but a tool call that, a series of tools that this agent would use to perform some specific action. So the functionality of this AWS Bedrock agent, this restaurant agent that we're going to build with AWS Bedrock, is to create, retrieve, delete table reservations. So we're going to, if anyone wants to create a booking, they could do that. Answer any questions on menu items, they could do that. And also it will maintain context during conversations and personalize the interaction with the customers. These are 4 important features that this agent has that we're going to build today. And also, if you see this specific part of the action group invokes something called a Lambda function. So what is a Lambda function? So Lambda function is a serverless function within AWS. So a serverless function is something you don't have to worry about deploying it on a server, or it is something that actually it works on a server in AWS, but you don't have to worry about running it all the time. It is event driven, so it only executes when it's a piece of code that only executes when there is a specific event that happens. Maybe you're trying to upload your picture and you want the picture to be processed, maybe resized and stored somewhere. Maybe you need a service called Lambda that can do that piece of compute. And that is event driven. So event driven is when a specific event happens, and that is when this piece of code will run. And it is used a lot in most of the applications. You might have already been using it in your enterprise, or if you are using Azure Functions or Google Cloud Functions, these are all similar. And this is DynamoDB. So this is where all of our bookings would be stored. DynamoDB is a NoSQL database. It's not a SQL, just NoSQL. So it is from Amazon. They host a NoSQL database that will store everything as collections, and it is basically stored in JSON format within this database. So it's pretty scalable, very low latencies, and it is very powerful database. And usually Lambdas are integrated with this. And if you see here, Lambda function is able to update and feed all of the data within this. So any booking that you're going to create, or the agent will create or delete, it is all done through this process, where a specific question to create a booking is this agent will make use of this tool, which is this entire thing would together call a tool, where a tool for it is to go ahead and add that booking into a database. And this is the workflow on how that is happening. This is the Lambda function, or the piece of code that is actually doing their updates. And this is the tool call part of it. And but this is basically a simple pattern that we have seen here on how agent using a tool to perform a specific action. And we're going to see the RAG part of it, because now the agent should also able to answer questions on the menu items. So you see here, this is the part where the RAG comes into picture. The knowledge base is actually something that we will upload to our Bedrock. And here, in order to ask a question, just like how RAG works, when you ask a user question, a retriever will retrieve chunks of data from, chunks of data that you upload to your vector DB. And here, this documents are your menu, because you are basically asking questions to your menu card. That is one of the features that we mentioned here, where you can ask detailed questions to your menu card. So this is where the RAG part of it is taken care of. And Amazon OpenSearch Serverless Index is basically acting as a vector DB. And here, the S3 bucket is basically object storage. Think about S3 bucket to be like Google Drive, right? You use Google Drive if in case you want to share, files which are really huge, maybe your images. Just like that, Amazon has their own service called S3 Bucket, which is an object storage service. You could not use Amazon DynamoDB here. It is a different kind of storage for storing heavy, bigger files, or blob storage files, which are images or files and videos to be stored here. And so that's how agent is able to ask. This is one more tool section where agent could able to ask any questions or answer any questions to your menu through this workflow here, where you have this menu knowledge base, and given a question, your user query is actually converted into embeddings, and this vector DB does a search of it and gives the answer back. Just a simple RAG that it performs here within our own knowledge base. So this is the diagram overall. We'll be implementing this step by step, and we'll probably go through the code after this. And there are a few things that we have will be looking at on the Bedrock side, which is the foundational model. So in order to perform any of these operations, we need an LLM, which is a large language model. In our case, we'll be using Cloud 3.5 soft sonnet model that is from Anthropic. It's a very famous model. They just came out with 3.7 like a few weeks ago. It's not available yet on Anthropic, so I'm just using 3.5 for now. It's a powerful model. It got really high accuracy and more of like it produces human-like response. And most of them use it for coding now. I mean, if you ask any developer, they probably are using Cloud 3.5 Sonnet for their maybe coding. It's really good at it. And action groups are basically different functions your agent could perform, just like a tool call or a function call, where to get booking details, to create booking, delete booking, that's all done or driven through the action group that we were talking about. Just a name that they have given for this. It's to create to perform a specific action. You can create an action group, and this is all driven by this serverless service or Lambda that is performing these functions within action group. And knowledge base is something that we have just discussed here, right? So that's your knowledge base that is through, and this knowledge base actually these are different. These are different components. We'll go through the console now pretty soon. Console is the AWS console. I'll go through these important sections of Bedrock. Knowledge base is where you have all of your personal documents, and that is where we store our menu documents, and it basically automatically vectorizes and indexes PDFs. So vectorizing is basically converting that human readable documents into chunks and then converting them into numbers and storing them. So it automatically does that and also indexes them so that it retrieves them. And yeah, I think these are some things which we're gonna look at and implement today. So let me stop sharing this part of the screen and just share the console so that everyone can look at it. And yes, I'll share the PP. Is DynamoDB a vector DB? No, in this case. Yeah, I think they're great questions. Someone are already answering that. Yeah, thank you, everyone. I mean, I really appreciate that answering or taking these questions. So let me go ahead and share the AWS console, where we will go through okay, I'm just going ahead and signing in. Can everyone see my screen? The console is part of the screen.
Yes.
Yes. Yeah.
Yes. Awesome. Thank you. Perfect. So this is AWS portal that I'll showcase now. I don't know if anyone have already looked at this before, then it's well and good. But yeah, this is how AWS portal looks like. And we don't use much of AWS internally. We basically use other clouds as well, but this is some of the sandbox account that we're going to use today. So let me, and if anyone wants to work on AWS, and if you don't have your own account, you can create one, but please be very careful because they would ask for your credit card when you create it. And if you're not aware of cloud, and if you have some resources created up and running, you would be charged. So please be careful. If you're not aware of cloud, and if you want to go ahead and work on AWS, please be aware that you cannot just go and randomly create services, because there are some services that might just burn your credit card. So, just make sure that you know what you're doing and create some proper budgeting before that. And if you're already aware of cloud environment, okay, that's well and good. I don't know if AWS would give any credit. If you're a student, probably they have some free credits that they will give you. Maybe other users, maybe like $50 or something. I'm not exactly aware of the number, but yeah, please be very careful. Over here, so this is the Bedrock console. Okay, they have, if you look at here, they got foundational models. So these is where you would actually find a lot of your models, model catalogs, where you have a bunch of collection of models. This is the cloud model that is recently, okay, it's already there. I think Cloud 3.7 is already there. They also have DeepSeek R1. So it is a DeepSeek R1 hosted on AWS. It's not actual DeepSeek hosted in China. It's something, it's open source. So they hosted it in North Virginia region. So you can see all of these regions and they are global. So you can create your agents across across the globe. And, we are actually in North Virginia region. So any resource that we create today could probably be hosted within US. So you could probably see that all of these models here. There are open source models, there are closed source models, there's Llama model, except for OpenAI models. And they got different marketplace deployments. There's also a custom model fine-tuning option where you can fine-tune models or distill your models as well. Today, we're not going to distill any models. That maybe next, pretty soon, we might do a session on this where we can distill or fine-tune some models. But yeah, now we're not doing that. And they have Playground where you can actually play around with these models as well. And okay, I just clicked the Playground part. Let me just go reload that. Yeah, right here. So, and these are the builder tools. So this is where you can build agents. They have knowledge bases that we just saw, where we can actually create our knowledge base of in any documents that you want to chat with. And creating agent is pretty straightforward. You could just click on it, create agent. You can give it a name. You can enable multi-agent collaboration if needed. Multi-agent is if you're creating a bunch of agents that work together, you can do that. And when you create it, you can mention different aspects to this, like agent name, which service or which model that you want to select, what are the instructions for your agent, and what are the action groups for your agent. So all the things that we discussed previously, you could do that by clicking buttons, but we're not going to do that today. We're going to do this entire thing programmatically. So we're not going to click buttons and do it. Rather, we'll be doing that through code. And I'll go through that notebook very shortly about how we can build an agent through code. So, but if you want to just go ahead and click on these buttons and learn about this, it's pretty straightforward. It's pretty self-explanatory. You give a description, and there are some jargons that AWS specific jargons. If you're new to AWS, maybe it is difficult for you to understand something called roles and all. So AWS is actually a public cloud, so it's a shared responsibility model. So in AWS, if one service has to talk to another service, just like how we have seen in the diagram, maybe agent or Bedrock talking to lambdas or action groups talking to lambdas or lambda talking to DynamoDB, everything is controlled by a role or a policy, because those are because it's a shared responsibility model, and it's also every service cannot directly talk with every other service, and they don't have full access to it. So you need to explicitly mention what they could do. So that is something that we're doing today here. We will do that. We'll be talking about roles or service roles. So role is actually nothing but a permissions that your resource assumes. A resource, when I say resource in AWS, it's basically a service that I'm actually talking about. Those services include lambdas, DynamoDB, and even those AWS open source or open search, vector search, and all of them. So yeah, I think this is how you can create an agent by clicking buttons. But what we're going to do is we will go ahead and execute this from Bedrock, using Bedrock. I'm sorry, by using a SageMaker notebook. So in AWS, they have another service called SageMaker. So SageMaker provides runtime where it will have its own Jupyter notebook. So it's called SageMaker AI. It's a service from them. And if you see what I've done is I've created a notebook in this. And these notebooks are open source. So these are actually provided by AWS. If you want to go ahead and work on them, I can share you the links of the notebooks and also those GitHub projects. You can always go ahead and work on those as well. So here, if you click on the notebooks, there you go. This is the notebook that I have created previously. And you can just click on Open Jupyter, and there you go. You have this Jupyter notebook that is actually created. So SageMaker AI is actually providing us those notebooks. It's hosting those notebooks. And each notebook is basically a Jupyter notebook from which we will create all of this. We'll create this agent. And instead of clicking buttons, we're basically doing that through code. So you'll see all of those different sections. So what are we doing here? So we basically wish I had this diagram here. Let me look at this diagram. Let me open a yeah, I just want to keep this diagram handy. I know I could not swap between both slides on this, but I'll just create this. Yeah, so this is what we're creating. So so what do we need in order to create? So these are different permissions that we need. As I said, in AWS, before that, some decisions that we're going to make is, what is the foundational model that we're going to use? We should create a DynamoDB table to store the reservation details, and we should also create Lambda function that handles all of our reservations. This is the Lambda function that we're going to create, a DynamoDB to store our reservations. So what this restaurant agent is doing is it's creating reservations based on the user questions, and it is also answering questions around menu. But we will first create this workflow, and then we'll create the bottom one. So, and then here you're also creating an action group and associating that with an agent. And we're also testing the agent invocation. So these are some of the things that we're going to do with this notebook. And if you see here, these are the prerequisites. So these are something that we have to take care of. First thing is, we need to make sure that IAM roles are created. So previously, as I said, in AWS, when you create any service, you need to create something called role. So role is something that these resources assume. So without roles, nothing will happen here in AWS, because any resource to talk to any other resource, in our case, a Lambda has to talk with DynamoDB, or our agent has to talk with Lambda. This entire thing all of these integrations would only happen through something called a role. So you create a policy to that role and you tell, hey, just assume this role to talk to this other service. So that is what a role is. It's even complex. I mean, I don't want to take a whole session on role. I just want to give you a complete overview. If you're new to AWS, maybe you can just understand that it's just a permissions part of this AWS that is taken care of. That is something that you have to create. And we have to create Lambda functions, DynamoDB, and Bedrock. This is all done through code. We'll do that here, and as we go through this notebook. And these are something that your SageMaker Studio would have access to in order to create all of them. So today, these are the permissions that your studio should have. I mean, now if I want to create DynamoDB, my notebook itself should have permissions to create DynamoDB. It should have permissions to create AWS Bedrock. It should have permissions to create Lambda, because we're going to build all this from this notebook, which is from a different service within Amazon, right? So this entire notebook, or this specific notebook, should have these permissions to create other permissions as well. So if any one of you are cloud engineers here in this call, please don't. I mean, I know you would certainly be hesitant to do this, because you're never giving full permission is not an ideal thing, but this is just a tutorial where we're going through explanation, and this will require us to create some resources on the fly, but it is never a good best practice to actually give full permissions to a notebook. That to IAM full permission is a no-go. So I'm just for tutorial purpose. That's the reason why I'm giving this. I could make it more fine-grained, but I haven't done it because I know it takes a lot of iterations, and it's just for tutorial purpose that I have given this. So please don't blame me for that. So let me just go ahead and execute this. So first thing is, there are some modules that we're going to import here. I've previously executed this, and that's the reason maybe it's not showing you that installation here. So these are, we have some agent code that is within this, that is creating these classes, or this module is actually creating DynamoDB, creating Lambda, create Lambda rules. So these are different resources that it is creating, and you'll see them here. You're importing those specific methods. And if you want to implement this in production, there are tools like Terraform that you could use that can actually create these resources for you, and also a pipeline to do that if you are actually doing this in production. But this is just a simple example. And let's go ahead and execute this part of the code. So what we're doing here is we are basically using Boto3. So Boto3 is the client. Boto3 is a module from AWS, where if in case you want to create S3 buckets, or you want to create DynamoDB, all of these resources, for Python to understand AWS, this is the module that actually translate, or this is the module that will make your Python to understand all of your AWS and everything. So you're creating client for S3 because you need S3 bucket to store your menu cards and all. So, and you create and you create different clients to create AWS Bedrock or Bedrock agent. You also create clients to create Bedrock agent runtime, because there are two parts to this Bedrock. One is to create something that does just managing booking, and something that actually does RAG. So there are two different Bedrock agent runtimes that we're using here. And we have loggers, and this is basically an account ID and the region. We are operating off US East 1, which is in the North Virginia region that I've shown you through this console. So that's what it's printed here, the region and the account ID. Account ID is my AWS account ID. And what we're going to do here is we are setting up this agent information. Previously, if you see, when we're clicking buttons on the screen, while creating this agent, we were just clicking the buttons and giving a name for our agent and all of those. So let me go back and show you that part of the code, maybe in AWS Bedrock. So we are basically doing the same thing, but now programmatically. So we're giving the agent name, description, what are the agent instruction, and we're also providing these details. So we are doing that, all of it here through code. Previously, we were able to do that through the screen. So I'm just going ahead and executing that here, where this is the action group that is created. Instead of me going ahead and performing that everything manually here through agents. And when you create agent here, you can see, description, and this is the name of the agent that you can click on it, and then you add description, the model that you select, and instructions. So all of those actions are done through code here. We're giving the name, and here you're giving the Bedrock policy name, because policy name is the permissions thing that this Bedrock would need to interact with other services. And this is the role name. Role name is what your Bedrock actually assumes to interact with other services. So we're giving those different names. It's all metadata that we're going to create for our resources. So, and this is the agent instruction, that what your agent will do. The same thing that you're going to give here for the agent instructions. And then you have this action group description of what is an action group. And you can also see those action groups here within this. When you're adding and you have a name for the action group, you have description, and you also have what you're going to do with this action group. Either it is a Lambda that you want to trigger, and you can select one, or you can create one. Similarly, we're doing the same thing here through code. So you're just giving the name for this action group, and that's what we did here. So I'll just go ahead and execute it. And now we are selecting the foundational model. Basically, we are selecting the model as just how we do that here within the agent section, where we have a bunch of options to select. Just like once you create this agent, you have an option here to select the model. So we have all of these options. So we are just taking two options here, which is these are two options that we're going to give to our agent, and which is 3.5 and 3.5 haiku. We are using this specific value. If you see the drop down here, there's only two. So programmatically, we'll select 3.5 sonnet, and there you go. So we selected this model that will be powering our agent. And once it's done, you have that value that is initiated here, and there you go. So now the agent foundation model is Anthropic Claude 3.5. And next part is to create the DynamoDB, because this is where all of our bookings will be stored. So the table name that we're going to create is the restaurant's booking, and you can just go click on it, and it is going ahead and creating this table called restaurant's booking. And you could observe that on the dashboard. If you want to go ahead and check the DynamoDB section, which is our DynamoDB service that we're creating here. And you can see that we are creating, or the table might already be created here. Restaurant bookings. This is the one that is created already. This is being created from this code. So yeah, there you go. The restaurant booking is created successfully that we have seen previously in the DynamoDB section of AWS. And since we are done with the DynamoDB creation, so we're done with this part of the code. Now we're going to move and create the Lambda function, because this is the compute that is going and updating, and there's a piece of code that will be updating or removing your bookings on DynamoDB, which is our storage, right? So right here, this is the Lambda function. So this is the Lambda function. We are basically creating a new file called Lambda function.py that exists in this Jupyter Notebook runtime here. We are basically pre-populating that file here, and then what we're doing is we'll go ahead and create roles for this Lambda function, because as I said, roles are important. Those are the things which are taking care of the permissions. So you would create those roles, and this is the Lambda function name. And now this is the method to create your Lambda function. So this is, and after I click this basically went in and create a Lambda with this name, and this is the IAM role that it will assume, the Lambda function would assume. And I'll just go ahead and execute this part of it, which is the role that we need to create for our agent. But before that, I think we can go ahead and check if our Lambda has been created. I have previously ran this specific notebook, so these are already created, but you could still look at it here. What is the name we have given here for this Lambda? We can check that right here. Basically create Lambda and agent name. So we have basically given our agent name as the, we are creating this Lambda based on the agent name. So the agent name is booking agent. So we can go here and search booking agent. So there you go. This is the Lambda function that got created a minute ago. So, and this is what this Lambda is doing here. It's a piece of code that we have just written here and created this Lambda. And you can see it is all configured through a specific triggers. And what it does is it it has to get the booking details. It has to create booking. It could delete booking. These are different actions that the agent would perform through this Lambda. And Lambda is a compute layer that is executing this part of the code to delete, create or get bookings. And where is it doing it from? It's actually performing this action from this Lambda runtime, and it is performing this against DynamoDB. So that is how it is integrated with both of them. And yeah, there you go. So now we were able to perform this specific Lambda creation. Next comes, so this is a step that we have implemented, and we created these roles. And now what we're going to do is we'll create our agent. So we're creating an agent role. So the agent role is really important because the agent role would basically create roles that are needed for your agent to interact with different services, because now agent has to talk with your action group and also talk with other services. So you define what it has to do. Your agent would be talking to all of Bedrock, because that is what your agent is doing. Your agent actually is using Bedrock as a service. So we are telling, okay, it can use Bedrock, and this is the basic service that service role that it creates. You can see the response here. Yeah, there you go. This is the service. This is the role that you've created. This is how it looks like. Role is basically a statement, a JSON that is telling what all permissions does your agent has. An agent should have full permission to AWS Bedrock, and that's what you see here. It got AWS Bedrock execution role for agent, and it could allow all of these actions to assume itself to be AWS Bedrock agent, and that is what we're doing here. And now you see with all of this information, we're going ahead and creating that agent. So we're going ahead and creating that agent with all of these steps. So you could see that this agent has been created now, and these are the steps that follow to create the agent. And then comes the agent ID that is displayed here, the agent that is created. And this is all created on the Bedrock side, on the Bedrock console. You can actually check that in the console, and then it is assigned this ID. And next, we're going to create the action group, the agent action group. So this is what's controlling the agent action group, is what has your Lambda. So your agent is triggering or assigning the task to this action group, which will invoke your Lambda to perform all of your booking and all of those actions. So all of those operations. So and this is how your action group is created. So action group, you're telling your agent, you're providing it with all of these functionalities on how or what parameters that it has to pass to your Lambda, because Lambda is piece of code, right? This piece of code would require different parameters to perform specific action. So when you're creating this action group, you're actually this action group is actually used by the agent, and you are defining here all the parameters that you need to pass to perform these actions. First thing is to get the booking details. All parameters that you need is the booking ID that need to be passed to your Lambda, because your Lambda would need a booking ID to retrieve that specific booking. Create booking. So this would require it to create a specific booking. And in order to create a booking, it requires date, it requires name of the person, it requires hour, what time it has to do the booking for, and number of guests. So these are important questions that you probably need to have, and you pass these as a parameters to your Lambda to go ahead and do a booking. So if you see some fields are true, it means that these fields should be there in order to do the booking. If these fields doesn't exist, then it will probably ask you a follow-up question to do that booking, and then we'll see that pretty soon. And here you have a delete booking, and delete booking would only need the booking ID to delete. So these are all parameters that your action group has to provide to the Lambda to perform a specific action. It's more of a tool implementation within AWS that we'll be seeing here. And now we have done that. And what we're going to do is we're just here, we're going and creating this action group. Now we have defined what action group is. Now we'll just go and create that programmatically. So yeah, now let's go and see if it is created. I'm just waiting for the response. So it might, and these are all different metadata that you probably need for your action groups to be created. You need your agent ID, your execution role for your Lambda, and there you go. You got the response 200. So your action group is created. So there you go. The action group is created now, and next part would be to allowing Bedrock to invoke this Lambda function. as we created the Bedrock agent, but we don't have permissions for this to trigger this specific Lambda function. So we're going and creating those policies here, basically creating allow permissions to invoke Lambda. So that is what the statement looks like here. You'll see what is the action. It has to trigger Lambda or invoke Lambda, and this is what is able to do. This is the principal is what it is, the resource that is able to invoke that, which is Bedrock. So Bedrock should have ability to invoke Lambda, and this is the policy that we're creating here. So I'll just go and execute this part of code, and there you go. It just replied back and saying, yeah, it is now this is integrated. These permissions are there. And now we're going ahead and preparing our agent to run. So we're just preparing it, and you can see that it just gave you a response here. So what we're doing is you're just have everything properly packaged, all of the security configuration, everything is packaged properly, and this is just having your agent ready to accept request. That is what we're trying to do here. And we are invoking this agent. There's something called as an alias ID that we assign to the agent. And this is the question. There you go. We created this agent now. I mean, not entire thing, only the top part of it is what created. So the ability for the agent, now the agent has the ability to do the bookings. So given a question, it will just go ahead and do the bookings, and we can test that thing here. It says, hi, I'm Anna. I want to create a booking for 2 people. It will be for tomorrow at 8:30 p.m. So let's go ahead and invoke this and see if we're able to create or not. So I just executed it. And if you see here, this step also has a session ID. So session ID is what it creates a specific session. The session is very important because this will maintain the context of the chat. Imagining this, you chatting with this agent or some others chatting with agent. Everyone would have their own session ID. Every session would have its own memory, its own context, because my booking is different from your booking. So that's all managed with the session ID. And this is the query, which is the question that is asked. And you're just invoking your agent with this query, which is to create the booking. You're creating the session, you're providing it with the session ID that is created here. And agent ID is which agent to be triggered, and there's an alias for this agent ID. And there you go. It just went in, did the booking, and then you can actually see that it actually did this booking and stored it in our DynamoDB database. And yeah, now our agent has ability to do this. And let's say if it is not, maybe even if you don't put the time and just execute this, you should able to see some follow-up questions asked, because we know in action groups, we knew there are some fields which are required, right? As of now, we just ask it, hey, can you create booking for 2 people? But it should get information to book that or confirm that booking based on the date, what time, and also under what name. We haven't done that. So we need all this information to perform this booking successfully, right? So that's the reason you see this follow-up question, because in our agent or action group, we have put these fields to be true. So the Lambda would only be invoked if these parameters are available, which is number of guests, hour, name, and date. These are important parameters for your action group to trigger your Lambda to go ahead and do the booking. So that's the reason why, since these are true, you would see this follow-up questions which are asked by your agent to confirm or to create the booking. Okay? So now we know that our agent it can probably succeed the booking and also ask follow-up questions if it doesn't have enough information. So what are the next steps? So now we have to go ahead and have our agent ability to ask questions regarding our menu. So in order to do that, we will be doing this rack pattern that we discussed before, right? In order to do that, what we're going to do is, first thing is we're going to store all this information that we have done from this part of the code. And then we're going to this part of the section where we're associating this knowledge base to agent. So what's going on here, right? So basically it's a simple rack. So we need to have this menu cards or this data, which is our own restaurant menu card, to be put into a vector DB and basically search through that given a user query. So we're going to create that. So now I'm going ahead and, creating this, importing these modules, and I'm just creating, just like previously, I'm creating these 4 to 3 clients to interact with, or to create IAMs, or to create Bedrock agent, and to, also interact with S3. And here we are setting up knowledge base information. So we have to create the knowledge base. So we know on the console how to create the knowledge base, because within the Bedrock console, you could actually see those knowledge bases and everything already. There's an option to do that, but we're just giving that metadata from here, just like since we're doing this on the code. And now we're going ahead and creating this knowledge base for Bedrock. So in order to create this knowledge base for Bedrock, there are some things that we need. Okay, what are those? First thing is Amazon OpenSearch Serverless. What is this OpenSearch? I don't know how many of you are familiar with Elasticsearch. So Elasticsearch is something that Amazon. So Elasticsearch was open source previously. Later on, Elasticsearch went, closed source. Though, but even then, that part of the code which was open source was actually managed by Amazon, and they changed the name to be OpenSearch. And they also incorporated vector database capabilities into that OpenSearch now. So that is what's happening here. So this is the vector DB, and it is one of the services from Amazon. You can search for those here, and this is where your knowledge base is. This is the knowledge base that you create, and you can see the knowledge base already created. But if you want to create it, you can create a knowledge base with vector store, and in order to do that, you have different options here to do that, and you have an option to create multiple data sources for those vector search. In our case, our vector DB itself is OpenSearch that we're going to use. So this is the open source service that we're going to use, which is acting like a vector DB. And there are also other vector DBs many of you might be familiar with, like Modus or Pinecone. There are a lot of other things like ChromaDB and everything. So those are all different vector stores. And this is the OpenSearch dashboard where you can actually create your OpenSearch vector DB and all of this. So yeah, we're doing that now programmatically, and we also create AWS IAM roles and policies, because as we already know, seen through all of the previous sessions, all of the previous sections, without permissions, there's nothing possible with AWS. So we're creating IAM roles and permissions so that our agent can talk to, OpenSearch vector service, or this can talk to S3 bucket, right? So let's go ahead and implement this and execute this part of the code that is actually going ahead and creating a knowledge base. So it's basically have this specific class that it gets from this runtime here. If you want, you can go through this. And this is part of the code that is performing a lot of things under the hood, like creating your vector search and also initiating, creating or retrieving knowledge base and all of those actions, creating S3 bucket, creating Bedrock execution rules. So all of these are actually done by this class, and we're just abstracting that here. But yeah, so you have this knowledge base created, and you have the data source also created. And what we have to do next is to upload these documents into S3 bucket. So you see there's a S3 client that is created. So you're uploading that file, and you have this document that you need to upload. So I'm just executing this, and there you go. It just ingested this menu cards into S3 bucket. All of your data resides in this S3, and which is your menu card resides in S3. And if given a question, your Bedrock would make use of this vector DB to answer questions from this data source. We have already seen this diagram in RAG pattern, where how RAG works, which basically search through any user query. It actually search through this vector DB or retrieve those chunks to answer your question. And there you go. We just go ahead and we'll be creating these different this part of the code that actually synchronizes the knowledge base. So what it's doing is the knowledge base is it's actually initiated, and it's available to our agent. And you're also performing this, you're testing this knowledge base here. So once we know that this entire thing is ingested and stored in S3, and vector search or OpenSearch is integrated with that S3 bucket. So we're just going ahead and checking if it's able to answer some question. And this is the question that we have. We're just testing it out, and we're also providing all of the configuration for our knowledge base, which include, our ID of the knowledge base, the model ARN, that is the foundation model that is able to answer the question to this. This is the LLM that we're going to use, and we know we chose Cloud 3.5, and here you're providing all of this vector search configuration. Number of results is how many chunks it is paying to retrieve, and we have chosen it as number 5. So these are chunks that we will retrieve. And I'm just going and executing this. So the question that we are asking is which are 5 mains available in the children menu, and there you go. These are the mains that are available. So it's able to query the menu and get the answer from this. So yeah, now we can test and see that our knowledge base is properly created, and you're able to chat with it. And now what we're going to do is we need to integrate the agent to allow to able to interact with knowledge base to retrieve and generate queries. So this is the part of the code that we're going to take care of, where we have created S3, we have created this. Now we also created the knowledge base. Now the next part is to integrate this agent to be able to use this knowledge base to answer your question. So that is what we're doing to this part of the code, where we have booking, where we have all of this policies, which is the permissions for your for your Bedrock to retrieve and generate on this knowledge base resource that we have created. So this is a permission or the policy that is needed for any integration here on AWS. And then there you go. Right here we have, we're just going and executing this. And there you go. So now we have this integration done where now the agent can talk with your knowledge base. And just this, I mean, this is actually creating all the policies and IAM and permissions to enable agent to talk with knowledge base. And this part is actually associating or integrating it. And you can see this associate agent knowledge base, and you're providing all this metadata, and it will go ahead and associate with this. Let's go ahead, and once it is done, we go to the next step. But hopefully you all are observing some patterns. So every resource that we create, we are looking at different roles and permissions that are needed. If you're already previously worked with AWS, you are already familiar with it. If not, you're actually seeing that through code here. In production, usually all of these permissions or any AWS resources are handled by cloud infrastructure as a code tools like Terraform, CloudFormation templates. In this, we're just handling that through Python. But yeah, in general, it would probably be something that be done through something else. Okay, yeah, it's just saying that it already exists, nothing to worry about, it's not an error. So let's go ahead and prepare this agent. So there you go, we're preparing this agent that, where just previously we have done that. It's basically initiating all of the configurations and everything. And now we can go ahead and ask questions. So now this part of the code is done where we are able to integrate the knowledge base to our agent. And we can start asking questions on our menu. So how are we able to do that? Just this is the question that we want to ask, and there you go. You can initiate that. This is the question: what the status in children's menu? It just goes and gets that answer for you through this knowledge retrieval. I'm just giving it a few seconds here. Maybe it's taking time to initiate. Yeah, there you go. So this is the answer. It's able to read the menu and get you this specific answer. So what are the status in the children's menu? So then comes, we're just storing all this metadata, all these things that we created as part of this previous steps, which is knowledge base information and all of this other resource information that we created, metadata related to this, so that we can just go ahead and start invoking our agent and asking a few more questions. So I think, okay, let me just go ahead and do this initiation here. And then we have something called session attributes, prompt session attributes, and all of them. So we are not, if in case we were to build an actual application from this code, there is something called session ID, as previously said. It's basically differentiates my sessions, my interactions with the agent with your interactions, because, my account would probably be different to your account. Maybe my reservations are different than your reservations. So this is what session ID maintains. Every session or every question, if you are initiating with a new session ID, it means that there's a new session created, and programmatically it is handled. If in case you're building an application, maybe a cloud native application with it, it's all programmatically handled. As of now, we're just doing this entire thing through code. So I'm just explicitly mentioning what all sessions are those, and also prompt session attributes are, we're also passing some more metadata to that session to retrieve specific information for that session. It could be looking related to my name, or it could also be, retrieving some information with a date or time. So that entire thing adds up to your prompt, and they call it prompt session attributes. So yeah, now let's go ahead and just select all from DynamoDB. We're selecting all of the bookings which were done previously, just to check what are the current bookings in DynamoDB that we have. And there you go, there's one booking because we created that Anna booking previously. Now what we're going to do is, so we just tested that this booking exists in DynamoDB. And now we are going to, again, invoke this new session with a specific session ID that creates a new session and asks this question, which is what's in children's menu. I was able to answer that soon. So I was able to answer this. And then what we're doing is, if you see this, which is what is in children's menu, and we created a new session ID. But when you ask a follow-up question, this follow-up question should be linked to the previous session ID. So we haven't created a new session here. So the follow-up question should able to link to the previous question, which is what is in children's menu and which of these options are vegetarian. And the session ID that is passed in is the previous session ID that we created. So it should able to take this as a follow-up question to this. So that is how we are create this context for session ID. And if you see this question should able to get this question should be treated as a follow-up to this previous question that we asked related to the children's menu. So there you go. Now you see some of the vegetarian options that it is providing based on this previous question on the children's menu. So yeah, I think you could also create with the action group. So I think we already seen this demo before, like we can just give it a name and ask it to do a booking. And here we've given all of these details, and it just goes on, create this booking, and we can just go ahead and select from DynamoDB to check if the DynamoDB booking is already done or not. One of the value that this adds is, when you want to select this DynamoDB, this statement is actually helpful for us to evaluate if our agent is able to actually create an booking with that name and with that time. If not, there is some issue with our agent, and we will refine our prompt or refine our integration. So it's really the statefulness or this DynamoDB that is adding the reservation is also acting as an evaluation source of truth to check if it actually did what we asked it to do. If not, we can improve the system. So that definitely this statement will add a lot of value to this, and also this persistent information would also help us to audit if our agents were able to perform the action that we asked them to perform, including the time and the booking ID and the name that we got and the number of guests. And yeah, there you go. I think this is what it is. We were able to build this end to end. And if anyone wants to run this, I can share you the GitHub code as well, and you can just start doing it. And after this, we're just going ahead and cleaning up all of the resources that we just built, because cleaning up is really important, because these will cost us money. So it's always better to delete them. So I'm just went in and deleting some of this resources here. So yeah, I'll go ahead and share this, and I'll go ahead and take some questions. All I see is your R. Oh, I'm sorry. Where it can see view. Okay. Yes, Graham, I think you can build lambdas. Yeah, you can build agents as well. I mean, this is, if you know how to build lambdas and how you can create IAM roles and policies, yeah, just go ahead and start creating agents. Definitely, you can do that. Between Cloud 3.5 on AWS Bedrock and directly calling Cloud from Anthropic, which one is more cost efficient? I mean, both of them cost the same. It's just you're calling AWS, and AWS happen to be the investor in Anthropic. So the only difference is if you're using Cloud directly from Anthropic, you have to handle the other resources separately, right? Cloud doesn't provide you with storage. It doesn't provide you with databases. It doesn't provide you with permissions. It's just a raw API that you need to call and then interact with them. But if you're using with AWS, you can actually build a cloud native application. So cost effective. Basically, if you're just talking about the tokens, it's the same cost on both of them. But only thing is, if you do it through AWS, AWS, you're just paying for all of the other things. Just like, if you just go buy, maybe, a chicken from Costco, the $5 chicken, you definitely buy something else as well, right? On your way out. Same thing is happening with AWS. They are providing you the same cost, but, you definitely buy something else from them, maybe the compute or storage. I'm always confused between, okay, this is some question that maybe someone answered here. A lot of the previous questions, I think, Disha, I think you got the answer. So yeah, you can write lambdas in Python and many other languages. Yeah, build an agent using code. What we don't have programming knowledge is Lambda written in Python. What we don't have programming knowledge is Lambda written in... Yeah, Lambda could be written in Python or Node.js. And if you don't have coding experience, you could still do all of this by clicking buttons. Anil. So you don't have to actually do this through code. The reason why I have done this through code is because, if you happen to be a developer and you can basically understand this, and if you do something through code, it is easy for us to go back, reiterate, audit any changes. Anything done through code is safe. If you really want to put something in production, it has to be through code. So that is the reason why I have done this through code. But if you really want to go ahead and click buttons and do it, you can do that, because you can just go into AWS, get into Bedrock service, and just click buttons. But I would not recommend that in case you're building a huge model or building a huge model with different integrations. But if you want to just start out with small ones, you can still do it. It's just that, it takes time, and it will sometimes, it might not, you might do some mistake, because humans, we definitely do some mistakes. So that's the reason why doing everything as code is a better approach. I know. Haven't done programming, I have been in cloud engineering or operations. So, if you have done that, yeah, you could actually do all these integrations. If you just want the code part of it, you could just get the code from GitHub. But, yeah, I think if you just you are into cloud, you have done engineering or operations, but if you are already familiar with Terraform and all of it, yeah, you could do that as well. Yeah, but there are good answers from people here. Can we feed the sensitive data model training in Bedrock? Are there any risk? So for model training, sensitive data. So see, the thing is, it's up to you to maintain the pre-processing. So you need to filter it out. And this is the great feature. I think I've missed it. And not missed it, but they do provide something called AWS guardrails that can help to filter out that. If you see here, there are something called guardrails that you can create, and these guardrails they will filter out sensitive information, block out prompts that are not that has some harmful information and all. So you can create those guardrails here. Previously, I think I've created one guardrail, but yeah, you can create those guardrails to do it. That's a Dhaneshwar, and I think it's a good call out there, providing this specific service. I haven't covered it here yet because this notebook doesn't have the guardrails, but yeah, guardrails are very important in case of going into production. Can we get this notebook? Yes, Graham, you can. I'll probably share that. GitHub, AWS Bedrock. Yes, there you go. So this is this got a bunch of notebooks. So you can check this out. This is a project from them. So yes, I'm sharing you the GitHub is shared. I'll share you the YouTube link that we have all of our previous sessions on RAG. I'm just going ahead and share you that here. Yes. Is it possible to build a simple version of this solely on a desktop? You could build that locally as well, but yeah, because AWS provide every service source that you can spin up locally. Even SAM CLI would allow you to create lambdas locally, simulate lambdas locally as well. What are the ways we ensure that answers are consistent when a question is repeated to the LLM? I mean, the answers are consistent when a question is repeated to an LLM. I mean, to get the consistent answer, yeah, they are different. For the LLM, there are different ways in which you can set that through temperature and all. And so that way you can, get this. And also, consistent answer is also means that if, in the backend, what is your data source? And because in our case, it's data that is stored in a persistent database. So I think you can set those parameters as well in order to get the consistent answer. Yeah, I think I've answered quite a few here.
Hello.
Presentation. Thank you for yeah, Bhuvan, go ahead.
Quick question. So when the LLM is sending the query and along with maybe like the data in like JSON format to the agent, correct? That's the trigger.
Yes.
And
yes.
yeah, sorry. What were you saying?
Yes, I mean, let me just open up my slides here so that I can look at flow diagram. I can showcase that. Can you see my slides here? Yeah. So I just want to give you this. Yeah. Okay. It's a RAG pattern that you're talking about. Yeah. Go ahead. What's your question now?
I just want to understand like the LLM is triggering the agent. How like the LLM creates some response and are we reading it every single time? Or are we reading it only when like the query is like are we doing another like vector kind of thing on the LLM query to see if it matches our agent and then only are we perform the agent?
I think in that other diagram, the LLM is missing. So if you could maybe go to that agent diagram, Rajan, kind of explain there.
Yes. So let me just go ahead and showcase the diagram. The main diagram, right?
Yeah, where the agent and the action groups are there.
Yes, like here. So right here, this one.
Yeah, we don't see the LLM.
Yes, this is the LLM. The agent is a wrapper around LLM, right?
Got it.
This is the LLM. So agent is nothing but a fancy call to an LLM. So that is what an agent is. But LLM, if in case it has to perform an action. So what this agent does is based on the user question, it routes the question. If the question is related to booking a table, the action group triggers that. So what does it will extract is, if you see here, the action group that we created, it does have where is that? I have, yeah, these are the parameters. So based on your agent functions, so if you're trying to get bookings, and these are the parameters. So if it's, based on, this is what defines what it has to do. This is what triggering your Lambda, right? So if your question has something to related to with, get bookings, which is to retrieve details of restaurant bookings, or this is the description of creating a new restaurant booking. So it would get all these details from your question and then trigger your Lambda. In order to create a booking, it has to get all of these parameters basically from the user question. And that is the trigger point for your Lambda. But your LLM, it's basically the agent, the restaurant agent itself, this has the LLM in it. So this is where the LLM is receiving your question, it is interpreting, it is doing the proper planning of it, how it has to be able to, perform your request, and then it is just going and performing, doing a tool call, which is, the tool here is your action group, which is saying, which is defining these lambdas and all. It is giving a trigger point for your lambdas with all of the necessary parameters to perform that action. And
Correct.
if it is a question, related to menu, then it will route here. Yeah. I don't know if I answered that. Yeah.
No, you answered pretty well. So like the information showing right now on your screen, is that part of what the LLM produces and feeds the agent?
This is what that this information which I'm showing right here is what it's basically a tool call, a function call that your LLM would your LLM should be able to extract based on the question and then send that to your Lambda, because these are the parameters. For the Lambda to trigger, Lambda is basically a function, right? For the function to trigger, the function should have various attributes, and this is where it is extracting these attributes. And it's your LLM that is actually doing this. It is extracting those parameters and then giving that parameters to your Lambda to trigger and go ahead and do the booking. So that's something that your LLM is doing here through this function call, through this tool call. Yeah, the agent.
The agent is just a wrapper on the LLM.
Yes.
And the LLM is the one that does the natural language processing, gives the request to Lambda. Lambda processes it, but the actual menu information is coming from OpenSearch, correct?
Like yes, because if your question is related to the question is related to menu, then it goes into this. It does a RAG here.
Makes sense. Makes sense.
And there is something called, the reason you might be, confused, like how does LLM is doing that? So these LLMs have some ability to call something called function calling or tool calling. So they are able to call a function. That is what's happening here. They are able to do this function calling, and that's the reason why you see these functions are defined, where it knows which function to call and how to call and give these parameters to that function. So you're not doing that explicitly. You're telling, hey, this is what these are. You're not directly giving all the information to you, but your LLM itself knows which function to call based on the question, extract those parameters and give that to your model. And these LLMs are really good at it. It's called function calling or tool calling. You can look at this. There is a whole leaderboard for this. They call it VFCL, which is Berkeley Function Calling Leaderboard, which is really important to build agents, because if your agent doesn't know how to do a proper function calling, means it doesn't know which action to take. You can review that.
Wow, thank you, Raj. Thank
you. Any other questions anyone has? Hopefully that answered your questions, Bhuvan.
No, that did. Thank you so much.
Thank you. Yeah.
Excuse me, sir. I had a doubt.
Yeah, Rashmik.
So, basically, like generally, if we use any AI bots for our purpose, like there might be few edge cases where the customer might not be satisfied with the response of it. So that time you might want to talk to a human, right? So I just wanted to know like how the human in the loop is, how important is that aspect of a human in the loop for AI agents.
So human in the loop is really important. In cases where you are taking some important business decision, like let's say, do we need to give a refund to the customer or not? Right, human in the loop is definitely needed there, because you can't have an agent just give refunds to everyone. But if it hallucinates, then probably the business might lose money. Then the human in the loop is needed to validate what your agent is doing. But in document retrieval and answering a question related to a menu, I don't think it's really business impacting, right? In this case, I don't think human in the loop is really that important, but still evaluation is definitely needed, because now I can't say agent is perfect. Based on some questions, maybe your agent could go ahead and does not create proper booking. So you probably need evals to be run. So you need to create a benchmarking, you need to create evaluations. How do you check those evaluations? Because now you have DynamoDB table that has that has auditable information to check if the agent is able to actually go ahead and create the booking with the actual name and the timing or not. So based on that, you have this human in the loop which will verify or validate those responses, or you can use LLM as a judge as well. But in this case, we don't have any human in the loop because of it's a simple booking system. It is not business impacting. But definitely for some critical decisions making, human in the loop is always needed. And I always advocate for human in the loop because these tools are just cognition driven tools, are intelligent tools, but still they can hallucinate, they can make mistakes. So based on your business use case, always have human in the loop.
Yeah. Thank you, sir.
Thank you.
Hey Raj, this is Vikram here.
Here we go.
Yeah, thank you for the session. Really informative. Just a quick question on taxonomies and ontologies. I just recently attended a session, so I don't have the full knowledge, but maybe if you worked on like ontologies or taxonomies, I was just thinking, is there a way that we could improve the agent by establishing those semantic relationship, by defining synonyms and etc., so that the agent becomes more richer in its response? Or maybe you could also see that the users are using certain kind of language, for example, sweets instead of just desserts, and kind of learn over time to establish those relationships and make the agent better over time. What are your thoughts on that?
So basically, LLMs are really smart at understanding those those synonyms and all of those, because these LLMs are trained on vast amount of data. So if you go into ChatGPT and ask it, like, can you give me synonyms? They can probably give like all the synonyms that exist. So they are aware of it. Unless you're using a small language model which is not that capable, but these big models like Cloud or even and even OpenAI, I don't think there's any issue with these models. They already has that ability to they already have all of these taxonomies and synonyms baked into their model parameters. So we don't have to explicitly even train them on that. Unless it is something that is internal to you. Maybe you have your own project and this project has a different project name and it could also have some synonyms and taxonomy which is personal to you, which where this ChatGPT was never trained on it. Maybe there you can probably do some training, but if it is in general, yeah, they already are aware of it.
Gotcha. And probably do like a graph rag or something, right?
Yeah, graph rag is possible, but in that case, you're getting a more complicated associations of things. Then yeah, maybe to eliminate hallucinations, you could do graph rag. In this case, maybe if your menu card, it's only few pages, right? Probably that would fit in your context. But imagine you have this entire compliance documentation of like maybe 100 or 200 pages, which will have very interrelated dependencies. Then yeah, maybe there you need graph rag because you need to know auditable information. You can't allow your LLM to hallucinate because compliance is really important. Then yeah, graph rag is definitely needed there.
Sounds good. Yeah, thank you very much. I appreciate it.
Any other questions, anyone? Not seeing if anyone has any chat question in the chat, maybe I will see your. Okay, let me check. Okay, yeah, I think no other questions. Yeah, it's a PDF. The knowledge base is in PDF. Yeah, we can build agents that can manage AWS costs. I mean, I think they're already doing this. Where do you integrate MCPs? Yeah, that's a great question, Joseph. I mean, MCPs are really taking off. MCPs in action groups, maybe, but MCPs are something that is basically adapters to some external tools. So if in case you have some external tools like GitHub that you want this to integrate with, then yeah, maybe you can create your own external MCPs to interact with it. So it will happen through action groups and through Lambdas. So they can directly interact with your Lambdas will be the clients for the MCP server. So that is how it happens. Yeah, that's why it's through action groups only. Yes, agent functions. Yeah, this Lambda functions does look like MCP-like code. I mean, MCP client-like code because MCP has a client and server. So yeah, these could be a class clients that can interact with external MCPs. Yes, this recording will be available, Vikram.
Raj, I have one question.
Yes.
So these agents, right? How it can be developed as an application? For example, any front end will be deployed to invoke the agents. How it will be like? How we can use it as a package application?
Yes, I mean, you can create a front end, you can create this backend. Bedrock actually has a ability to expose this agents as an API, and then you can just create an application layer, a backend layer that is talking to Bedrock APIs. So just like any cloud native application, you can do this. Maybe a front end and back end. And if you have worked with any AWS cloud native, have you worked with any cloud native application before, Chandra?
Yeah, so I work as
Yes.
microservice. So, okay, so
Yes. Yeah, just like any other cloud native application, because Bedrock is just any other service, right? So you can do
okay.
that.
For example, right? So here, if you want to use any other model, right? LLM model, how we can we configure in the Bedrock?
Yes, you can. Bedrock has a bunch of models that you can use.
Okay. Yeah, thank you.